Hi, I'm Ethan Merchant, and over the past 4 years, I've been setting spatial interactions free at dofdev. Today, I'll be going over what I've learned, and hopefully get you more interested and invested in XR interactions and getting them open sourced, because we can do better. So, jumping straight into it, I have a sort of example of my own. So, back in 2018, started making a game based on missile command, adapting it for VR as just a way to, get past the hurdle of just making a full game, getting it out there. Because I've done that in the past with other flat screen games. So trying to get the most out of the VR hardware when there was just like such a core, simple experience. The choke point at that point really became interactions. So for you to get the most out of it visually and experientially, throwing the player in the thick of it, as you can see here, just right in the middle of everything, 4-meter radius of missiles and other things just flying in at you, really made for an engaging experience. But you needed to accurately target points out in space within that radius, which is not something I've seen a solution for as of yet. But because, once again, this very simple core underlying game concept, trying to get the most out of the hardware, and being a bit stubborn, we ended up just iterating on this interaction. And through that process, we ended up stumbling upon something that we thought was pretty cool, pretty unique at the time. I ended up calling it a stretch cursor. So any sort of take one step back from there. So once we came across this, it was very clear, in our minds at least, that this is something that we should make more available in the world, and not just lock down and hide it inside our own private code base. And so that's when we started figuring out, okay, what do we call these things? How do we communicate them to other people? How do we make better ones? How do we make more of them? And it just got the ball rolling for dofdev. So you can see right down here, we have a side view. We'll click through to see it a little bit closer. So this side view really makes the interaction very clear. And to be fair, this is not super advanced interaction. Other people have figured out similar things by now on their own. But as you can see, there's a relationship between these two controllers where we're able to calculate out a delta by subtracting the to vector from the from vector. And from there, we get a direction we can use and a stretch value that we can use to extend a cursor out. So just that diagram alone is pretty useful. You could probably just from that reverse engineer it, figure out how to implement it into your own code base. But when you get to more advanced interactions, or if maybe this seems a little bit daunting given your current skill set, then it can be really worth it to make a spatial pattern. That's what we have down here. So a spatial pattern, if you really want to be pedantic, is just a pseudocode. But I'm calling it a pattern because it gets away from the word pseudo, like fake code. I'm not really trying to point out that it's fake. And so instead, called it a pattern. So the reason why it's called a pattern is other people, as well as AI, are really good at picking up on patterns. So if you communicate things in that way, it ends up just being a lot clearer for everyone involved. If you're trying to communicate something to the computer as well. So, which in the case of code, that's literally what you're doing. So we have a general sort of structure that might seem familiar to anyone that's done, XR code or game code or any sort of real-time experience. And that is to kind of break things out into input, data, frame logic, and design variables. And I'll go line by line in just a second, but I thought it'd be more engaging if I showed how easy it is to implement this into your own code base once you've put the work into making this sort of spatial pattern. One quick thing I will point out, though, is it is to the day the 4th anniversary of the stretch cursor, which is a little bit uncanny. Yeah, so what we'll do is we'll copy this out. We will switch scenes, hop over into the code, and we'll paste it right above into a commented out section. Now, by yourself, you could just look line by line and get it all implemented. But if you are lucky enough to have an AI assistant, that process can become that much easier. So so far I have the input. It's 2 vec3s, and now I'm getting the data. I have a float stretch value as well as a vec3 cursor. Now, let me scroll up a little bit. So I've got the pattern on the left. Let me move over to the right a little bit. Before we get to the frame, we'll get the design variables plugged in. So Copilot might get a little bit lost here and there, but if you rein it back in, it'll keep on cranking. So now we have the dead zone and strength variable. And now Copilot wants to get all the frame all in one go, but you can see it gets a little bit confused with some of these shorter formed words that I like to use. And in that case, if you just hold its hand just a little bit more, there's no need to put a comment there that says frame because the function already says that. We'll show it that we don't want it to just use MAG. We'll have it use the StereoKit specific magnitude. Then we'll crank out the stretch value. We'll switch this over to math F. Now, before we move on to the next parts, the magnitude is just we take the delta between those two controllers, or these 2 points, and we get the magnitude out from there, or the length of the vector. Now, the stretch value we calculate using the magnitude, and we subtract the dead zone design variable from it, and keep it right above 0, and that allows you to bring the cursor all the way in without smacking your hands together, which you might not realize you need to do until later. So having it baked into the pattern can help other people who are trying to implement this interaction. Next, we'll get the direction. Now, StereoKit does have a direction function. It's just not in the version I have right now. And cursor position just takes in all of those things we've calculated so far and extends it out from the vec2 using the direction times the stretch times the strength. Next, for the purposes of this demo, we will draw out some debug visuals. So StereoKit has these amazing immediate mode rendering functions. I'm able to just throw lines up out of nowhere in cubes. As you can see, we got one for the stretch, we got one going out to the cursor, we've got a box rendered out for the position of the cursor, so all good to go. Very painless. And yeah, this is something that I haven't seen other people push, and I see it as a very good way to open source these interactions. Just to reiterate, you should be able to do this with other code bases, other engines, and get similar results. Depending on your engine, if it really doesn't have that much vector math, you may run into issues here and there. But in those cases, I would recommend when you're making a spatial pattern to link to open source references for any code snippets that are a bit more esoteric. That way, there's still a path forward for them to implement it in an engine that has maybe less vector and quaternion math. All right. Let me bring my timer back up. Cool. So we'll hop back to the spatial pattern. So if you can tell by the border, this is just a embed, an embedded iframe. Once again, we're really over-optimizing for open sourcing things. So we don't want to be the single choke point of anything if we can help it. And so what this is doing is if you click right up there, that'll take you to the source control. In this case, a GitHub repo with the raw text version of the pattern. That way other people can contribute to this. And that way it's, has source control, so you can roll back things. And that way it's also easy for other people to host and show their spatial patterns in this sort of form. So the way this works is I'll grab this URL up here, and if I go to dofdev.org/pattern, I'm taken to this page. And you can see here, I can just drop in a GitHub pattern URL, paste it in, submit it, and I get an iframe that I can put wherever I want. And it will show up just like this does, which is super handy. Now, we're not against hosting other people's dofs on our website. If that's something you're interested in, let us know. Also, if you end up implementing one of our dofs in one of your own pieces of software, we'd love to hear about it and add it to a list. Underneath each of these dofs, we'd like to have like a list of things that's used in. That way we can really kind of see the impact of it. And rather than it just being like, it might be happening out in the world, we can like really show it. Just to go over what dofdev is relatively briefly. Because once again, we are kind of pushing different ways of doing things, some different terminology. So iterating it is kind of the only way to get that across. So dofdev is degrees of freedom development. And we are an effort to open higher degrees of spatial interaction free to the world. It's me and Nico. I'm on the engineering side of things. Nico's on the design side of things. So if you're looking to know how to think about these design spaces and really start grappling with them and applying them to different things you might have not expected you could do, then I recommend checking out Nico's talk, which is just after mine. So dofs, the definition of dof right now is sort of like, a degree of freedom, which is usually used for like robotics. So if you have something that can maybe move in like one dimension or rotate in one dimension, then you're like, oh, that's one dof. Or if you can rotate in all three dimensions, so it's 3 dof. You can move and rotate, 6 dof. So most people in the XR space are familiar with that word. And so we ended up finding that while that is a very useful word for very like hard and mechanical things, there's also an interesting interpretation of it when you take it from sort of more of a human perspective. And when we did that, it ended up being a very good term for these like principal proprioceptive remappings, these core XR interactions, where you can kind of build up quite a bit off of them, but they have this sort of core, unique sort of attribute or capability that wasn't kind of there in the world before. Once again, they are distilled into free and open source interoperable patterns. And we have a whole bunch of them on our site here. I do not have time to go through all of these right now. I recommend checking them out and seeing if they could be useful for you or for someone else you know. Yeah. At this point, I will open the floor to questions. Thank you.